All right, good afternoon, everyone. I'm going to introduce the Formel equations that go with kinematics. So kinematics is the fancy way of saying the equations that relate the four measures of motion: position, time, velocity, and acceleration. We already have equations developed from taking data and graphing it, and then we're going to just use these same equations and reorganize them, derive different equations that are helpful for other type of problems. Perhaps the most important aspect of this tutorial is to do and learn this problem-solving strategy. Yes, I'm going to give you new equations, but those aren't things you have to memorize. You'll have them written down somewhere or in your reference tables, and it's just an issue. Can you find the correct equation for the situation, and then can you apply it correctly? Like anything else you've seen in this class, there's a lot of detail in it, but with practice, you'll see, okay, it's not so bad. So before I jump into the problem-solving strategy and the new equations, let's review what we already know. So we have two equations at this point for average velocity. We can say average velocity is our change in position divided by time, the rate of change of position. And if we're uniformly accelerating, we can also write that as our initial speed plus final speed divided by 2. That's not time, but 2. It's always 2. So if I'm going from 30 miles per hour to 50 miles per hour, my average is 30 plus 50 divided by 2, 40, the halfway value. And then we also came up with an equation that says acceleration. The definition of acceleration is the rate of change of velocity, which can be expanded to your final minus initial divided by time. So don't confuse those two equations. It happens all the time. You can't get hard to confuse if you have them written in front of you when you're going to solve problems. So what I'm going to do is I'm going to derive one equation right now. I'm going to call it equation 3. Okay? It's a simple derivation. I'm looking at equation 2. So what equation 2 tells me the rate at which I'm accelerating is based on my change in velocity and time. Usually what we want that equation for is to tell me how fast I'm going after a certain amount of time if I'm accelerating. In other words, A is a given. I want to use that to determine what my speed is sometime later. So I'm going to rearrange equation 2 and solve for final velocity. So final velocity is just v. So if I do the algebra, I cross multiply the t here, and then I add the a, or the v naught, I get my final velocity v equals my initial velocity plus the rate at which I'm accelerating times the time. So that's a useful equation. It's really the same as that, but it solves directly for how fast I'm going sometime later, and it should make sense. If my acceleration is 0, then my final speed is equal to my initial speed. If my acceleration is negative, then my final speed is going to be less than the initial speed. In other words, I'm slowing down, and if my acceleration is positive, then the value is going to be greater. Okay, so let's do some problems and use these equations, and in the process show you what I expect to see in any problem that you do. Even if you can do it in your head, even though this is obvious, I still want to see this. Because what you're going to see is when we do later, it's not going to be obvious how to solve something. So you want to have a process. This process is valuable. So 5 basic bullet points. The first thing you do once you read the problems carefully is you determine what quantity is being sought. In other words, what is asked. And you essentially have the following you could ask for: time, position, average speed, final speed, initial speed, or acceleration. Okay? So you just got to identify that. That means you got to know your vocabulary. Once you figure out what you want, the mistake that many kids make is they jump to one of these equations. Before you do that, I want you to take another step, and that is determine what information you already have and literally write it down. It's the same players as we have up there. Now, I'm going to give you a little important point. If you want to solve something, you need at least 3 pieces of information in order to go ahead and solve. So when you're looking for what information I have, you need to find 3 things. Sometimes it's obvious, other times you got to infer it based on the information on the sentence. Then it's step 3. Then you go and find an equation. You should never have to guess at an equation because you've got your variable listed that you're looking for, you got your variables that you know, and you can find one of these equations that matches all that. Once you find an equation, write it down. Then you can plug and chug. Plug and chug means put in the numbers, chug out with your calculator and answer. And then lastly, reflect on the sensibility of the answer. Does it make sense? Part of to help you organize all that is a Vtex table that I've set up here, where we can, in this table, we can look at all the possible variables and fill in the information so that it's right before us to help us choose the proper equation. Okay, so let's do a problem. I have a sailboat, it's moving north, so that north is important, that's direction. It gives us 8 meters per second. A wind gusts in the opposite direction and accelerates the boat at a rate of 2 meters per second squared. That's just a fancy way of writing meters per second squared. First question, how much time does it take to bring the boat to rest? So the boat's moving along, wind blows in the opposite direction, slows it down to a stop. We don't know how much time. Now, many of you can probably figure this out in your head. The answer is 4 seconds. But I want us to show where that comes from, how you break it down. We're going to go through the process, and I expect this for every problem. And in fact, this table can apply to almost all these problems. So, first thing, what are we looking for? How much time? So I'm looking for t, so I'm going to put a question mark for the first box. The second box will come for a later problem. Okay, next, what do I know? In order to solve for time, I need 3 pieces of information. So I'm going to read things carefully. Sailboat is moving north at 8 meters per second. Okay, so that 8 means something. The question is, what does it stand for? And this is where kids often make the mistake. First of all, the meters per second tells me it's a velocity. So I didn't say the velocity is 8 meters per second, but the meters per second tells us that. Secondly, now I got to choose, is it an average, a final, or an initial velocity? Well, it's the beginning of our event. So the 8 meters per second is got to be an instantaneous, because if it was an average velocity, you would have to say moving on average. So it's either an initial or final. So this is the beginning of our event. It's our initial. So V0 is 8. I'm not even going to put the units. I'm just going to put the value there. Okay, there's one piece of information. A wind gusts in the opposite direction and accelerates it at a rate of 2 meters per second. So that should be pretty clear, and the units are, again, a clue. That's our acceleration. But the opposite direction we gotta be careful of. Opposite direction means that it's negative. If our initial velocity was positive, then our acceleration is -2. And that's an easy mistake or thing to overlook. So we got 2 pieces of information. Now I need a third. Wait a second. Our sentence ended. It doesn't say anything more. How are we going to get our third piece of information? And that third piece of information has to be either our final speed or our position. That's why this table helps us, guides us as to what to look for. Well, we have 0 information about the position, but if I read this problem carefully, I see a key word right there at the end, rest. Rest means our final speed is 0. Okay, now I'm ready to go. I'm looking for time. What do I know? So if I go up to my equations at the top here, I have an equation here that has time in it. This one doesn't help, right? This one has time in it, and this one has time in it. So which one do I choose? I choose the one that has the information about initial speed, final speed, and acceleration. So I can use either equation 2 or 3. I'm going to use equation 3. So I'm going to write first, V equals V0 plus AT. There's my equation. I'm now going to solve for t. T equals V minus V0 all over A. So this is assuming you can do your algebra. And that's why we did that the very first week of school. Make sure you can manipulate equations. Some kids like to put in numbers at this point. I'm encourage you not to do that. I'm encourage you to solve algebraically before you put numbers in for reasons that will become evident later on. Okay, now I can plug in Chug. So V is 0. V0 was 8. A was -2. I probably should put units in here. Meters per second squared. -8 divided by -2, sure enough, is 4. Meters per second divided by meters per second squared. I'll let you work out. Turns out to be seconds. There's my answer. Okay. So we knew it was going to be 4. You probably did that right away when you read it, or you thought about it a little bit, but this is the formal way of doing it. Okay, so let's ask another question. How fast is the boat moving after 6 seconds? Okay, so what am I looking for? How fast? Fast is a speed. What speed? It's an instantaneous, because it doesn't say how fast on average. Is it the initial or final? Well, after indicates the final. So in the next problem, okay, I'm not going to do V, I'm going to do it right here. I'm going to say V equals question mark. Okay, what information do I have? Well, after 6 seconds means now I know that the time that's doing it is 6. The information up here is still valid. So its initial speed is 8, and the acceleration is still -2. Okay, I've got my information. I know what I'm looking for, what equation. I'm going to use the same equation as before. I'm going to say v equals v naught plus at. Okay, so v equals 8 plus a -2 times 6. All right, I know my writing's getting awful here. -2 times 6 is -12, plus 8 is -4. Make sure you put your units. Okay, did I do anything silly here? I get a feeling, I feel like I did something silly, but I don't see what it is. Okay, well actually that makes sense. Because after 4 seconds, it comes to a stop, so if the wind is blowing for even longer, 6 seconds, that means it has to be now going backwards. That's what that negative means. So now I can ask, what's the average velocity during this? So again, I go through the process. Average velocity, that's v bar, question mark. I still have all my information over here. That hasn't changed. The mistake kids want to make as soon as they see average velocities, they want to do change in position over time. But if you look over here, I don't have any position time, so it doesn't make sense to use this equation. Is there another equation that helps me find average velocity? Sure there is. There is this equation right here. So I'll use it because I have the information. So I can say v bar equals v plus v naught, v naught plus v divided by 2. So our initial speed was 8. Our final speed is -4 divided by 2, and that gives us 2 meters per second. So on average, we were moving 2 meters per second. In other words, most of the time we were moving forward, a little bit of time moving backward, so on average we were forward. Then I can ask, what's the displacement after 6 seconds? And now I can say, all right, x equals question mark. I have all this information. I'm not going to rewrite it all. So what equation will help me find position? There's only one I have up above, and that is x equals our initial position plus average speed times time. It's super important I put an average speed there. Okay, mistake kids would put as an instantaneous speed. It's got to be average. So x equals 0. My initial position was 0. Average speed we just found to be 2. And our time was 6 seconds. So we've gone 12 meters. Okay, that's the process. Sometimes in homework I'll have tables for each problem. Other times I expect you to write it in the margins when you're working it out. Now, the question is, suppose, I'm just going to erase all this if you don't mind. Suppose I had given you the same information and I didn't ask this or this first. I just asked this immediately. What is the displacement after 6 seconds, knowing it was initially moving at 8, knowing that his acceleration was -2, and knowing that the time is that, right? Is there a way of calculating x directly? And the answer is yes. Okay, so what we had to do in order to find x, we had to figure this out first. We had to find the final speed, then to help us use that to find the average speed so that we could use the equation x equals average speed times time. Well, it'd be nice if we could do that directly. So I'm going to show you how we can take the existing equations and get a direct equation from that. So I've got a minute left, so I'm going to stop the tutorial now, and then I'm going to make a new tutorial to show you the derivation and the fourth equation, and then actually I'm going to call this the fourth equation, and then a fifth equation. Okay.